Hi, everyone. We're back again. We want to keep the discussion going about OpenConfig and different open management tools. And today we're going to take on the gnarly subject of Yang. So with me again is Dan and Tomas, and we'll let Dan take it away with the few slides on what exactly Yang is, how it works. And I definitely am going to be learning some stuff here too, because I'm pretty confused when it comes to Yang.
Yeah, I think a lot of people are. I laugh at you use the word gnarly because I don't want to say this is gonna be a little boring topic. It's a much necessary topic, but gnarly, yeah. It'll definitely be a fun time for a lot of understanding of how Yang works and how you roll into OpenConfig and what exactly it is. Slight disclaimer here. Yang is not the same thing as OpenConfig. So a lot of people mention the word Yang, and I'm sorry, Yang is not the same as netconf. You hear that a lot in the same breath in the sentence. Like people say Yang and netconf, use them both, where netconf is really just a transport. Just a little bit of a disclaimer. Yang itself really is just a schema. So what is a schema if you're not really used to using it? A schema is something that kind of defines the schema of an object. So for example, like even when you're sitting away on the CLI and you type something in like VLAN 1234, 1234 is going to be an integer. Like the CLI that you're using is going to know that that is the actual of type of a VLAN. Same thing goes with kind of like anything. An MTUs have to be integer as well. An MTU can't be 1500, 1234. Internally to Arista, like we have our own schema. Other network vendors, same thing as well. But a schema generally defines what type things are going to be, what type the data is going to be in general. And that is what Yang is. So Yang's nothing new. Like this has been around for quite some time. Yang and netconf kind of get interchanged together because I believe Fred or Tomas, correct me if I'm wrong here. Yang was what was around during netconf, and that was kind of the schema they used. But it's nothing new. It's nothing new. Like we referenced an RFC here in a couple bullet points, but it's been around for quite some time. So we talk a lot about like switches, obviously. Netconf. I'm sorry, I'm even confused myself here. Yang being used for switches, but Yang's actually used for like other things too. So like we have Wi-Fi. So like what's really interesting and fascinating to me is I found out that through a couple of people that OpenConfig was really being used for Wi-Fi models, and Yang was used for Wi-Fi models. That was like very neat. But we did that as well. Our Wi-Fi APs actually fully embrace OpenConfig, which is like pretty cool stuff. But today we'll talk about kind of like things like BGP interfaces, system information. All those things are described fully through Yang.
So when you talk about Yang being a schema, and I mean back to that first bullet where you're talking about how it lets you say that a VLAN ID should be an integer, or that an interface MTU has to be an integer. So does Yang protect you, or does that schema protect you from messing up and, like, let's say I put in a string or something for my interface MTU, or I put in a number that's just outlandish for my VLAN that's VLAN 20,000. Does that schema protect you from making those kind of goof ups in your configs?
Yeah, absolutely, because every leaf attribute has explicitly defined data type. And so, for example, VLAN names are defined as strings, or VLAN IDs have to be integers, and they have to be from 1 to 4094. And same for the MTU as well. So that there's pattern matching as well, and there are bound checks basically on all of the types.
And so that's all defined in the model itself. Like when we get into later on into some of the models, there will be stuff where I say VLAN ID or VLAN number should be an integer from 1 to 4094 or whatever it is.
Yeah, exactly.
Cool.
Yeah, it's basically a schema. Like it's like your car, like your tires have to be circles. They can't be like Flintstone cars.
Right.
Yeah, same type of thing. This is the schema.
Cool.
And just a quick example, like a interface, for example, even if you didn't really know OpenConfig, I'm sorry, Yang, anything like that, and you were a network engineer, you can quickly take a look at this. And this is just line 377 from the OpenConfig interface Yang file. You'll kind of see here like leaf. Leaf is basically what defines a piece of data. So like this piece of data is called MTU, and type is the most important part. So UNT16 basically means it has to be an integer. And it gives a little description of it and says, hey, this has to be an integer. And it's basically setting the MTU size on octets for physical interface.
So here, I mean, this is kind of cool. So when we talk leaf here, obviously we're not talking spine leaf, right? This is more of a leaf of, I mean, I'll put on my computer science hat. This is a leaf of a tree structure that you have, data structure. So the leaf being the last piece, right? It's not going to have anything else hanging off of it. But this kind of goes back to my earlier question, which I think is this is explaining. So the type of this MTU has to be an integer. In this case, that looks like an unsigned 16-bit integer. But in this case, they don't have a bounds necessarily because I guess MTU, you don't know what the upper limit of that would ever be. But if we looked at the same kind of thing for the VLAN number, we would see both this type as well as some kind of regex or something that would give you a bounds on what that range should be able to be.
Yeah, there would be a pattern. There'd be a pattern that would give you a number that would, you know, like I said before, 1 through 4094 or 96.
Okay, cool.
Yep. So this will be a pretty good slide that kind of dismantles a lot of this and kind of where Yang fits into OpenConfig and kind of just the lay of the land, the 1,000-foot view of everything. So before, Yang is a schema. So I have a quick link here. We'll just jump into the actual OpenConfig interfaces and just show you two here. So OpenConfig, if you want to, the best place to find everything for OpenConfig is the public OpenConfig GitHub repo. So you can kind of go through here and as we go through like this whole video series, we'll cover a lot of these things. But a lot of these things are here, but the public OpenConfig Yang models, and we'll explain, there are different Yang models, like there's IETF, there's vendor ones there in OpenConfig. OpenConfig is by far probably the most popular of those. But let's jump back into OpenConfig-interfaces. This is the schema itself. I know we had a kind of little blurb of MTU. It will kind of dismantle this entire thing. We'll talk about what this is, but this is where you find it. For most people, they're going to go and take a look at this and say, like, what is this? How, like, you know, like this on its own really does nothing for you other than kind of says, hey, like what things have to be. So like interface ID has to be a string, subinterface, we'll get into a lot of this. But this is strictly just a schema. Like you'll fill in the blanks here in a little bit, how all the rest works. So it's strictly just a schema, like I said before, leaf MTU has to be an integer. And basically that leaf MTU, like I said before, has to be 1500 or it has to be a number. 1500 ABC123 is not acceptable. So therefore it like should fail when you create a data model. We're going to create a separate video on this, but basically there you have to take the schema and you kind of have to fill in the blanks. So MTU, so you have to at some point say, hey, in your data model, which is your OpenConfig data model, I have an interface ETH1 and the MTU is 8,000 or 9,000, for example. Like something actually has to fill in the blanks for me and has to do some type of what you call rendering to fill in the blanks and then create a data model. And that's what YGOT does. So YGOT is basically the Golang implementation and PyYang is the obviously the Python implementation of both. We have links in here to how to get to either one of them. And we'll do a quick PyYang demo in this as well. Fred, Tomas, feel free to add anything here you want to.
Do you see any kind of, I mean, let me back up for a second. So, because I think we're jumping back and forth between OpenConfig and Yang kind of already, and that's very natural here. So, So the relationship between OpenConfig and Yang is the schema that's defining what your data models in OpenConfig are going to be, right? Is that the right way to kind of think about it?
Correct. Yeah. Not to throw more confusion at everything, but Yang is just a schema method. Like
right.
It's really all it is. So like you could have a new set of Yang models called threads Yang models tomorrow. Right. And you could use in that schema how to define something, you know, it could really be anything. It could be a computer, a car, as long as you kind of use like these groupings and then use the leafs and kind of define it in that method. But OpenConfig is basically just a way in the public for other vendors to implement Yang models of their choosing.
Right. Yeah. So Yang is the schema definition language, but it doesn't actually define any particular schema. And then OpenConfig is a schema that's been defined in Yang. I guess.
Yep. Correct.
Right?
Yeah.
Cool.
Yes. It's a very good description of that. And then basically like these two programming languages, let's look at like PyYang real quick here. And Rob Shakira, who did this from Google, did it very, very well on this project. But we'll kind of skim through a lot of this. But basically what you could do is kind of take a model like OpenConfig local routing, and you'll see here like you run PyYang against it. And we're going to do a lot more of this. But you take this model, you throw some code at it, and basically it'll create either XML like this. Well, there's some JSON in here, or it'll create some pretty JSON like that. And that's basically like your data structure. And we'll talk about that here shortly. But once you actually do use YGOT or PyYang to kind of render something, that something could either be in either type of encoding you want to. So it could be in JSON or it could be in XML. Strictly speaking, the majority of this is going to be JSON. The only transport that uses XML is going to be netconf. Mostly everything's going to be in JSON. But here's just a quick example of just the data structure for just simply creating a host name. So you'll see here openconfig-system:system and config hostname CEOS1. So that would be a valid OpenConfig data structure just for that. I mean, a lot of people, they'll just render the entire thing, but because this screen is only so big, I wouldn't be able to fit the entire JSON on that.
So that's what you get after you run YGOT or PyYang on your OpenConfig file. You get this kind of encode JSON or XML encoding as what's spit out.
Correct. Yeah. I mean, just for simplistic, without anyone who's ever running it, like you would just basically somewhere in your code have a string called CEOS1, and what YGOT or PyYang bind do, or they kind of break a Yang model into programmatic languages. So today, like we'll just use PyYang because most network people use Python. It'll take structures of Yang and basically turn them into like tuples, dictionaries, classes. And then you could reference that in Python, like you import literally a file and then, kind of throw some data at it like CEOS1 and it'll output this.
Okay.
I make it sound like it's easy. It is not easy. That's why we have a whole video, we're going to dedicate to that after this.
Cool.
But once you actually do have this, we call it data structure in JSON, your next point is going to be like, hey, how do I actually configure my device with OpenConfig? Or how do I actually get data from a device? And what will that data look like? So we used GNMI last time. And like we said, GNMI is probably the most popular. GNMI uses gRPC, which is HTTP2, which is protobufs, blah, 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 a bunch of word salad there. So that's the most popular transport that we typically see. The other one's going to be RESTconf, and RESTconf uses HTTPS ACID transport. And then lastly, you have SSH. So this is kind of the 1,000-foot view of farm the table Yang to config. If that is a good example or a good idea.
So okay, so there's a lot of stuff. Like now, let's compare this to the old school method of good old SNMP, right? So in SNMP, I can kind of do, everybody wants to migrate to this kind of Yang, OpenConfig, RESTconf stuff. They want to move away from SNMP to this. So what's kind of what are the benefits that I'm achieving by shifting from one to the other?
So SNMP also uses a hierarchical format, which is very similar to the container leaf formatting that Dan described. And but in case of SNMP, it's using MIBs or management information base, which contain a bunch of variables, which we call object identifiers or OIDs, and you can then read or modify these values, but you can subscribe to them, as SNMP is poll based. And MIBs, on the other hand, are defined using a subset of ESN.1, and so they have this very non-human friendly formatting, like .1, .2, .1, .100, and so on. So it's very hard to remember or work with these, because there are thousands and thousands of these OIDs, and some MIBs obviously they do have names, but you still have to know the OIDs, like interface identifiers. And the thing about interfaces, for example, is that indexes can be different across different platforms. So for example, on one platform, Ethernet 1 can be 10,001. On platform, it can be just one. Whereas in OpenConfig, Ethernet 1 is Ethernet 1 everywhere. And also, probably you wouldn't use SNMP to configure your network, and I don't really think many people have succeeded using it, especially in a modern network. With OpenConfig, it's just much easier because you have path elements, and everything is well defined. You can easily loop through lots of data and update the config of a bunch of paths.
Cool. Yeah. So to some, I mean, make sure I understood all that, because I think there's a lot of stuff there. One big one is human readability, right? Instead of going down, 1.2.100.60, whatever, you get something that's much more understandable. You get the ability with OpenConfig in particular, I guess, to, or even maybe some of the other ones, to subscribe and do things where I'm going to get push. It's more of a push model as opposed to having to pull every 5 seconds with SNMP, which kind of sucks. And then I guess some better uniformity when it comes to how your data is structured. So you're saying, like, across the OpenConfig models, you get a lot better standardization, I guess, when it comes to what different path elements are named, versus, I guess, in SNMP, there's a lot of variability, especially when it gets down to the kind of lower levels of the MIB.
Yeah.
Cool.
Could you imagine being a developer, like they can, like, not have a network background and be like, wow, SNMP, like, without knowing this and like having to look at it, like, man, that would just be awful.
Yeah, I mean, I got to imagine and this is just totally me guessing, probably SNMP was optimized for a time when sending this kind of structured data would be intensive, right? So they just went with a lot of integers, which you can send over the wire very cheaply and decode very cheaply on the compute side. But nowadays we have a lot more bandwidth and CPU at our disposal.
And some of those were set to like 16 or 32 bits, so you couldn't even cover 10 gig interfaces there, which
There
is
you
really
go.
funny.
Yeah, there you go. Cool.
Fun times here. All right, so we're gonna kind of go through the Yang model for OpenConfig interfaces, and I kind of blast through a lot of this. Like, I think it's important, but there's just kind of a lot of bits and pieces here. And I'll kind of use the slides and back and forth and talk about a lot of this. First and foremost, you have the module. So the module says basically what Yang model you're going to use. So this Yang model is called OpenConfig interfaces. Next portion we're going to talk about is the version. So this is pretty important. The way this works is every major release, you'll get like version 1, version 2, version 3. So it looks like OpenConfig interface is only at 1, but you'll find some things are at 2 or 3. You'll have minor releases, which will be 1.2, 1.3, 1.4, and so forth. One major thing to know is that if you sort of sit on a version and then try it for something newer, its major versions are not compatible. So 1 is not compatible with 2, 2 is not compatible with 3, and so forth. But most of the time, 1.2 will work with 1.3. Just the way it is.
Real quick, Dan, could you zoom in on that a little bit? It's
It's a new laptop.
Your eyes are a lot younger than mine.
Oh, that's funny. All right, hope you can see your
Yeah, that's better. Thanks.
your elderly eyes can see this better now, right?
Yeah.
Okay. Prefix OC-IF. So for each one of the Yang models in OpenConfig, or it could be any one of the different Yang models, basically, well, let's cover this first. So OpenConfig interfaces itself, it actually needs other things as well. So these are not really self-explanatory, that these imports that are on here, but just like a programming language, you would typically need to import another package that refers to something you need. So this is not a good example, but let's say, for example, we had the BGP model, and BGP needs to redistribute OSPF and vice versa. You would actually import the model for OSPF, because you would have to know what the, let's say the router ID or the OSPF process, like that has to be an integer and so forth. So you're gonna have a lot of times that, or pretty much all the time, you're gonna take one Yang model and it's gonna import other Yang models. And then you'll see here, like prefix, like you'll refer to this as IETF-IF. So it's the same thing in programming languages where you import something, but you refer to it as something else. Organization, pretty typical, who owns this? Contact, description, those are going to be, fairly obvious. The one thing to talk about is like revisions. So every single time you do a revision to this, so let's say you did something here. So they added a leaf, well, leaves, however you want to call this, for management and CPU interfaces. So every single time, and this is all publicly on Git. I know it's slightly confusing because you keep this in source code like anything else. But if you look at the actual RFC for Yang, it'll tell you whenever you do any type of update to something, whether it's a leaf or a container or a grouping, you actually have to go through and put that you had a revision and what the reference is for that. Even though it's stored in source code, it's just kind of what the RFC says you have to do. Want to add anything to that? I have it here in the slides, most of that.
So that reference number or that version number that you have there, that's not the same as the version we saw back at the top of that file, right? You had a Yang version at the top, like in this case, Yang version 1. But then down here with this revision, you're gonna, I guess, is that the version number for this particular module or?
For this particular Yang model, just okay. The reference. Every time you do it, it'll uprev and reference. So reference 2.4, 2.3, 2.2. Even though you have commits, you still have to do those. But yeah, those are different from the actual, the Yang, the major Yang model.
Okay.
All right. So there's a whole, that file is pretty big, so it's probably best to just kind of go through the actual Yang model here, kind of what's important. So any single time you have like a something, so like this is called interface ID. It's called a type def. So you're kind of describing almost like a custom data type, I guess you could say. So you have type defs for like MTUs, you have type defs for all kinds of sorts of things. And then basically you'll say like, what this is going to be a type string. And it'll define sort of like what this generally is and give you a quick description of that. Containers and groupings are very similar, but it's basically a collection of something. So you have a collection of interfaces in which you're relevant to use. So within your collection of interfaces, you're going to have leafs, you're going to have nodes, you're going to have a whole bunch of information. It's kind of like almost like, if I were to give it an example in a programming language, it would almost like be like a class, an interface, or a method and everything below it. So under container interfaces, you're going to have things like leaf for like MTU, enabled, and so forth. But just know that your container is kind of a container. It's a collection of things, not to be confused with like, containers in the Linux world and such. Well, now it could be Windows as well, but leaf. So leaf is basically something that holds data in its most basic form. So leaf enabled, this is pretty obvious. This will be under interface. So it's going to say what the type is, a Boolean. So it's going to be either interface eth1 is enabled, true or false. So honorable mentions here. So list. So you're going to have a list, which is a repeated amounts of data. So you're going to have what's called leaf lists. So you might have repeated fields that are within your container. We'll talk about this a little more too, like config and state. So basically with every single model in OpenConfig, or I'm sorry, in Yang, you'll have a config tree. And basically what a config tree will say is, this is RW. So obviously you can read or write to it on the switch, or a state, which is just going to be like, hey, I want to like pull data from this. It's not actually writable.
Would those be two separate, I guess, let's say in this case, you have the leaf here, right? For whether something is enabled or not. Would you have one leaf that's read only and then a different leaf that's read write? Or how does that work? Or is it a completely different tree? Like for when I have my configuration world versus my kind of read only world?
Yeah, so basically everything's the same tree. So like you'll have like this big tree. It's actually in the demo.
Okay, we can wait for that then. That's cool.
Yeah. I'll explain it. But basically like you'll pull the OpenConfig path for interfaces. And OpenConfig path for interfaces, like it'll have interface and it'll have like counters, for example. And counters, like you're obviously, you can't influence counters. The only thing it really can is bandwidth.
Mm-hmm.
So those are going to be RO, those will be under state.
Okay, got it. Okay.
Something like this, like enabled, you as a human or, a machine, it'll be able to actually talk to the switch through one of the transports and flip that to either true or false.
Gotcha.
So that's what we're gonna do.
Cool.
All right. So one thing we'll talk about too is like, I think I kind of touched about this briefly, but one of the most commonly used Yang models in OpenConfig is going to be network instances. And this kind of throws a lot of people off for how this works. So most people are like, hey, I run BGP. Almost like every network runs BGP on their network, and they typically always look for the BGP Yang model. But one of the most popular one is going to be the network instances. And here's an example here. I think I have it in my text editor as well. Of network instances. So we'll just go to release. And this is simply just the you guys could see this good, right?
Yeah. I mean, it could I could do with one more zoom level in, but it's readable.
Better.
Yeah, that's better. Yeah.
Okay.
Oh, even better.
Okay. No pun intended as for using Zoom. But in the network instance model, you'll see all of these here. This is probably the most used one. And the reason for that is like, you could see how this imports like everything. So import things like IS to IS, PIM, IGMP, EVPN, OSPF, VLAN, blah, 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 blah. It's pretty big too. How many lines we got here? Oh, wow. Yeah. So we have like roughly 1,200 lines. But this is one of the most commonly used ones. And the reason why is because this kind of covers like all the network protocols. So like I said before, like, BGP needs OSPF, OSPF needs BGP. But if you have like this one network instance model that kind of covers like all the routing protocols, it's going to be really commonly used. So I figured I'd just kind of toss that in there. But this imports like so many things. So this is a good example too of like how this actually imports like so many different other Yang models and how they're used and such. Now I know we Fred Tomas talked about this, but OpenConfig is not the only set of Yang models, and this is where it starts to kind of unravel a little bit here. But there's going to be Yang models for IATF. So this is IATF interfaces. This is owned and managed by IATF. And like I talked before, like it uses Yang constructs. So you'll see namespace, version, identifier, everything else, kind of like we talked about before. The IATF interfaces are just described using the Yang schema. Then we have the OpenConfig interfaces, which is the same thing, being defined in the Yang schema, has everything else the same. That you could actually go to the OpenConfig GitHub for the public models and pull this down and play with it. And that'll be there as well. And then last one we'll really touch into are going to be kind of like vendor specific models. So this is our Arista EVPN experimental model for that. Now, as long as that model uses Yang to describe it, then it's therefore a valid Yang model.
So if I pause there for a sec, okay, I'm guessing I can understand why we'd have an Arista specific one versus say the IETF or OpenConfig, because we're doing things that either haven't been implemented yet in the standard ones, or we have some special sauce and we want to do our own thing to expose that in a Yang model. But why the divide between the IETF and the OpenConfig models up there?
Yeah, so
That's a good question. Well, probably like all of this started with the IETF group working on the first streaming telemetry related RFC, which was back in 2014, which provided the requirements for the PubSub services for Yang, for the Yang data store updates. And unfortunately, it took them around 5 years to publish the spec. And since this was taking too long and demand has been growing exponentially for model-driven telemetry, the OpenConfig working group was born, I think 2 years after that, so back in 2016. And they started focusing on streaming telemetry, which gained a lot of traction thanks to its open source code and tooling approaches. And initially, OpenConfig didn't cover everything that the IETF folks spec'd. But today they are almost identical with a few exceptions. Like with OpenConfig, we use protobuf encoding with gRPC, and IETF might use Yang push. And I guess it will be up to the market to decide which one to use. But probably today, the OpenConfig models are more popular. So if someone has been using OpenConfig for years, then probably they still use OpenConfig, and maybe new customers could decide which one to use and test both of them and see what are the differences.
So would you say, like, even today, are the OpenConfig ones iterating quicker than the IETF, which I kind of would expect given how slow the IETF generally runs? But
yeah, exactly, because the OpenConfig working group is consists of lots of cloud titans, and it's open source, so everyone, it doesn't necessarily have to be a big company, but even small companies who start with automation or build their networks using automation from day one, they can contribute, and they can implement deviations and augmentation, or ask for augmentations as well, and it's much faster.
Yeah, no, that brings up an interesting point. So let's say I am using OpenConfig, but I have something that's in my network that hasn't been done through OpenConfig yet, and maybe my vendor hasn't done it yet either. But there's some piece of data that I want to get to. Is there some way? You talk deviations and augmentation. Is there a way for me to kind of extend the model myself, just for my own personal usage, and then maybe submit that back upstream if people want to adopt that?
Yeah, exactly. So people can write deviations, and where they would implement their own feature set, which can modify the existing features, or just create completely new features. And you can ask also for augmentations, where sort of like an RFE, you would ask the vendor to implement something for your needs.
Cool.
yeah, and just generally, like, also too, the OpenConfig, like, there is an OpenConfig with the GitHub. Obviously, you could file for an issue if something you need something.
Sure.
And then too, like, there's a whole working group. They have a Google working group. This is a message board you can go through and submit that sort of thing, which is what open source is all about. But also too, Fred, your point, and Tomas, a lot of these cloud, a lot of the cloud providers use this, and for a long time, like, there were a lot of non-multicast features that were not supported. So, like, how would you, provide vendor coverage for that? So in our experimental models, we had to provide a lot of kind of trivial multicast usages outside of just your regular PIM, IGMP, and so forth. So that's kind of why that's there, obviously, for the coverage of, models.
Cool.
So talking about coverage of models, I pulled this here this morning just to do it, just take a look and see what's on there. In the GitHub repo for OpenConfig, just kind of seeing what's over there to the left, just doing a basic, tree on all the directories. There's a lot that's here. Like I did a talk in like 2016, and I think there were literally a third of what's there. So it's really cool to see things like Wi-Fi and segment routing and such. But yeah, it's stuff very neat. And in this picture here, like the image, it's pulled from the openconfig.net, I believe it is, just a basic, what's available to the device that they have in their public GitHub repo. So here it is. You just kind of go here. It's just github.com/openconfig/public. You can see here everything that's on here. This is funny. So I actually pulled this from 2017 from an older slide. It's been updated like a lot since then. So, and this is something we want to talk about too. Like, so basically within EOS, like you can go to our Arista network/Yang in our public GitHub. You need to actually see like what models we support, because these Yang models that we talked before, like these are uprev, revisioned, things are changed. Like today, for example, like you might have, I don't know, you might get something newer. So let's go back here. So you might not have had multicast support in OpenConfig back in 4.20, for example, or it might not have had segment routing or BGP VPN and such. But let's say in 426.2f, for example, we got those features. So basically, we'll actually have all the Yang models that exist within EOS code, like per version. So we store it in code, so you can actually go and take a look and see like what Yang models are there, what revisions and what are supported, and what augments we have in deviations and so forth. Okay, so this is basically a Yang tree. I know we talked about this. We're gonna do the demo here we've been leading up to, which is gonna be using a PyYang bind. So on my laptop itself, my MacBook, I have PyYang installed on here. So it's just gonna be simply calling a binary called PyYang and doing a -f, which is the type, which is gonna be tree, which creates the tree. And then what I'm actually gonna pull it from, which is the interfaces OpenConfig .yang. So here's what this looks like. So this is the public GitHub repo for the OpenConfig models. The one thing we need to kind of bring through to make a lot of sense here is that when you actually do this, you have to reference public release models. And the reason why it is, a lot of people, you try to go through this real quickly and just reference this. And the issue is that you have all these imports. So without importing all these other Yang models, it's just not going to work. So keep that in mind when if you do try this and you're watching this video and you try to import network instances, you're going to have to import, or you're going to have to reference everything as well. So that's sort of why that's there. So let me just close out the file here. And Fred, your eyeballs can see this, right?
Yeah, I'm good.
All right. All right. And basically we'll see the Yang tree. So when you're working with Yang pretty often, or OpenConfig and OpenConfig Yang in this situation, it's going to be, hey, either you created a Yang model or you want to see a Yang model that's human readable that you can actually play with. So let's see here, we're using the OpenConfig interface module. And then on top, we have interfaces, we have interface, and then it points to a name. So that's where it's going to be like ETH1, ETH2, and so forth. And all we talked about, like it's read writable. We have the name, the type, the MTU, loopback mode, and so forth, and description. State, this will stream back, but this is only the read-only version of this. Counter should be, so counters are right here. So these are the important parts that most people will pull. So in octets, in packets, unicast packets, and so forth. And then when you're using things like GNMI, you'll be able to stream this in live. And one thing too is some of these types might not look right to most people. Are like, oh, what's OC Yang counter 64? That's going to be a file that was imported, and it's going to have a type def of counter 64, which will have some complex regex within it. But that's pretty much it for Yang. I know this has been, we tried to keep this as lively as we could because schemas are slightly boring, unfortunately. But yeah.
Cool. So, I mean, I think we'll do a follow-up video. We'll play around with the CLI a bit more, dig in to using the different tools in another video, so we don't make this any longer than it already is. But yeah, no, thanks, Dan and Tomas. I think this has definitely helped me. I feel a lot more informed when it comes to the craziness that is Yang. But yeah, so let's close this one out, and then we will hopefully reconvene and do another one of these with a little more action.
Sure. Thanks, guys.
Awesome.
All right.
Thanks.
Thanks,
Yep.
guys. Bye.
See you next time. Bye.